Morning, guys. Today's lessons is on flow control and how to make simple decisions. You know where to find this in content. This week's assessment will be based on 1.6.1, which is flow control. We have the open book quiz there. Then statements and flow control, there's the open book quiz there. So we'll start on 1.6.1, flow control. So when we write, we can also write programs that ask questions, and based on the answer that we get from those questions we asked, we can use the answer accordingly. So how do we ask the question, is x equals to y? To ask this question we use the equal operator. This is one of the equality operators. So the equal operator, it checks if two numbers are equal. And remember, if you use one equal sign and two equal signs, these are completely different. This one is an assignment operator, which means you take one variable, you assign it to the next. But this one is the equality operator, which is the equal, which it checks if the value on your left is it equal to the value on your right. So if you ask a question, is 2 equals to 2? But your answer would be true. 2 is equals to true, right? That is true. But if you ask, is 1 equals to 2? What will be your answer there? Which is false. Remember, computer works in ones and zeros. If it's 1, that is true. If it's 0, that is false. You can also ask, is I equals to 0? But since we don't know the value of I, or the computer doesn't know the value of I, it won't give you an answer immediately unless you change that value of I such that I becomes 0. Then that question will be true. So what do we use if we want to see if the value on your left is not equals to the value on your right? Then you use this operator, this exclamation mark equal. We check, is A not equals to B? Do you see the difference? And how do we check if X is greater than Y? We use this greater than operator. I know you're familiar with this. We use this a lot in maths. And again, if you want to see if a value is greater or equals to another value, what we use is what we call the non-strict operator of the greater than operator. It's non-strict because we're checking the value of X and Y. It can be either greater than, or it can either be equals to. Do you get that? And if you look the way they write this operator, first you start with the greater than operator, then there's the equal sign. It's not the way around. You don't start with the equal sign, then the greater than operator, then you'll get something different. Or you'll get some errors when you do that. The less than operator, almost the same as the greater than operator, just that it's opened on the right side. We look if x is less than y. If it's x is less or equals to, this is how we do it. Use the less than operator, then the equal operator. Then if you remember our priority table, then our operators that we use to ask questions are right there under the binary operators in the priority table. Then the equality operators, equal, and not equal to. You can see where they are now. Condition and conditional exceptions. I think the following module explains this better than this one, so I will use that one to try to explain this, which is statements and flow control. So a statement in C++ is instructions that we give to a computer. And what's important is you must always remember that every statement must end with a semicolon. To mark your end of a statement, use a semicolon. That's what is mostly a programmer's nightmare. You write a big program and just leave out just one semicolon, and then you'll be confused where your errors are. It's always important to end your statements with semicolon. Selection statements, if and else. So in here you ask a computer, so here you ask a computer how to execute a specific block or statement, and we use the keyword if. So if, then you have this is the syntax of an if statement. So you have an if, then you have your condition and your statement. So if this condition is true, then execute this statement. That is what you are telling the computer. So let's look at this example, short example. You ask the computer, if x is equals to 100, then execute this statement. In this case, it will print out x is 100, because that is true, right? If it's false, then we'll have to use an else statement. I'll show you next. And if you notice here, if there's only one statement after your if statement, if there's only one statement, that statement is not enclosed in curly braces. But if you now have more than one statement, then you enclose your statements in curly braces. Can you see that? And another thing, you can write all this in one line, just like that, in one line of code. But between me and you can see that it's much easier to read that than it is to read that. It's still correct, you won't get any errors, but it's much easier to read that than that. Is that clear? Sure. So now he asked, what if He said, what if that condition was now false? Then we use what is called the else statement. So first we ask, is x greater than 0? If x is greater than 0, you execute that statement. X is a positive. Then, if x is not greater than 0, you have another if statement, which is the else if. You tell the computer, if x is not greater than 0, then execute this statement. Use else if x is less than 0, then x is negative. But if x is not greater than 0 and x is not less than 0, then that means x is just 0. Then use the else statement, else. Do you understand that? Does everyone understand that? Sure. And iteration statements, loops. We have the while loop, do while loop, and the for loop. Loops repeat statements a number of times, as long as that condition is true. So we'll first look at the while loop, and that is the syntax of writing a while loop. There's the keyword while, our test expression, and then the statements that will be executed as long as that test expression is true. So in here we have a program that counts down from 10. So how does it work? First we initialize n as 10. We give n the value of 10. And then we say while n is greater than 0. That is our expression. We check, is n greater than 0? If n is greater than 0, then we print out the value of n. Once we print out the value of n, remember what minus minus n does. We subtract 1 from n. So what's going to happen here? We give n the value of 10. Then while n is greater than 10, we print out, while n is greater than 0, we print out the value of 10. First we're going to have 10, then we subtract 1 from 10. Then we're going to get 9. 9 is still greater than 0, right? Then we print 9, and we subtract 1 from 9, that is 8. 8 is still greater than 0. We print out 8, then we subtract 1 from 8 until we reach 0. What happens when we get to 0? When we get to 0 now, our n is no longer greater to 0. It's no longer greater than 0. Which means now our condition is false. What happens when our condition is false now? Then we break out of the loop. That is the end of the loop. Then we execute this statement right after the loop, which is lift off. Can we try this? We can try this on C++ shell. Let's try 81. Do you see our output there? It printed out from 10 until to 1. Then when our value of n, when it's no longer greater than 0, then we print out the statement after the loop, which is lift off. This is step-by-step explanation of how that while loop works, which we just went through now. Then we have the do while loop. The do while loop is similar to the while loop, but it works differently. What's different from the while loop is it executes the statement first, then it checks the condition. Whereas the while loop, it checks the condition first, then it executes the statement. So let's see how it works. This is the syntax of the do while loop. You have the keyword do, then you have your statement while, and you have your condition. So we have this example here, which allows the user to enter any text as long as that text is not goodbye. Once you enter goodbye, then that's the end of your loop. So let's see how it works. First, it will ask you to enter any text. Then you'll print out the text that you entered. As long as that text is not goodbye, it will keep on looping. It will keep on asking you to enter more text. But once you enter the text goodbye, then your loop will end. Let's try it out. Still running. So I'm going to enter the text, hello. You see, it's still prompting me to enter another text. Let's say, hi. Still prompting me to enter another text. But if I type in goodbye, now it's no longer asking me to enter any text anymore. Then we have the for loop. The for loop is also designed to iterate a number of times. But this time, most of the time, is when you know the number of times that you want it to iterate. So this is the syntax for, keyword for, then you have your initialization, your condition, and an increase. This increase doesn't necessarily mean that it's always going to be an increase. Sometimes it can be a decrease. Then you have your statement inside that loop. So the first thing that happens is your initialization first is executed. If you see here from this example, this is your initialization. N is given the value of 10. Then we check the condition. Is n greater than 0? And then we execute the statement. What is our statement? Print out the value of n. And then the increase is executed. In this case, we subtract 1 from n. So let's see. N is equals to 10. We give n the value of 10. Then we check, is 10 greater than 0? Yes, 10 is greater than 0. Then we print out the value of n. Then we subtract 1 from n, which is then becomes 9. Then that will iterate until that condition is false. Once that value is 0, then n is no longer greater than 0. Then our loop will end, then print the statement right after the loop, which is lift off. And this is another form of for loop. It's called the range-based for loop. This is the syntax: for, your declaration, then the range, then the statement that needs to be executed. And in this example, our declaration is char C. Remember what char is for character. Then our range is this string that we declared at the top, which is hello. And then what this program does is it prints out this string as single characters. So if you look at here, from that range, how many characters are there? So it's 1, 2, 3, 4, 5, 6. Then it prints out this string as single characters. Like you see, it prints out hello on its own. It prints out, print out the H, E, L, L, O, and the exclamation mark as single characters. Then we also have jump statements. We have the break statement, continue statement, and the go-to statement. So what does the break statement does is, while you are doing this, while you are in your loop, maybe there's certain values you want to check, and if that specific value is found while you're still in that loop, while that specific value is found, then you can tell the loop to end right there. So it can override the condition of the loop, because you tell it, if you find this value, just stop there. Okay, so with this example, it's still a loop that counts from 10 to 1. So in the use of a for loop, say we have the initialization, the condition, and the increase. So we give n the value of 10. We check if n is greater than 0. Then we execute our statement. In this case, we print out the value of n. But if n is equals to 3, then you tell the loop to break, to stop there. Then you print out this statement, countdown aborted, because you found the value of 3. Sorry. These ones. So this first one is for the whole body of the program. There's the second last one is for the for loop. And the third last one is for the if statement. Can you see? So from our output here, you can see that it was counting from 10, 9, 8, 7, 6, 5, 4, 3. Then since now we have 3, and you told your computer that if the value of n becomes 3, you should abort the countdown. Then the continue statement. The continue statement just simply is telling the computer to skip a certain value, or to skip the rest of the statements after that condition, or after that loop in that current iteration. So let's see how it works. Is again, they used an example as a for loop. We have your initialization, your condition, and your an increase. We give an initial value of 10. Then we have our condition is n greater than 0. We execute our statement. Then we increase. In this case, they subtract a value of 1 from n. But then we tell our compiler or our program, if n is equals to 5, skip the rest of the loop. Then continue again. So how did this work is, you will see from the output, first they printed 10, 9, 8, 7, 6. But now, if n is equals to 5, you tell the compiler, if n is equals to 5, continue. We skip the rest of the loop. Then continue to the next iteration. If you look from this output, you cannot see the value of 5 there. Do you all understand that? Can you see that? Then we have the go-to statement. The go-to statement allows you to jump from one point of your code to another point, making use of labels. So let's see how it works. First, we initialized n with a value of 10. Then we have the label. This is the label where we want to jump to. Then we have our statement, then we have our increase. Then they used an if statement. If n is greater than 0, go to this label. That is our label that we placed there. So if n is greater than 0, initially n is 10. So 10 is greater than 0, right? So if that is true, you tell your program, go to that label, my label. Then it prints out 10, then it subtracts 1 from 10. After we subtract 1 from 10, we get 9. The 9 is still greater than 0. Then you go back to your label. At condition is false. If now that is 0, n is no longer greater than 0, then you print the statement right after the if statement. Then you get that. Then we have a selection statement, which is the switch. This is the syntax of a switch statement. You have your keyword, switch, expression. Then you have your case. That is also a keyword, case. Then this constant is what you check against this expression. If this constant meets that test expression, then you print this group of statements. If that test expression matches this, the second constant, then you execute this group of statements. But if all these constants if all these statements don't match with that expression, then you can have a default statements that can be executed. So let's see how it works. In here they've shown the difference between a switch and an if-else statement. But if you see, it's like they are almost similar. Switch x. If x is 1, our case 1. So if it's like you're saying if x is 1, then execute this statement. But if x is 2, then execute this statement. Can you see how it's almost similar? Then if x is not 1 and x is not 2, then you have your default statement. The value of x is unknown. So that is an example of a switch statement. Okay, we are done for today. Do you have